we're going to first convert this into its partial fraction. So we will let this 2r plus 3 over r plus 1, r plus 2. We will let this be equal to p over r plus q over r plus 1 plus r over r plus 2. And I'm going to make use of the cover-up rule to find p, q, r. I think that is the fastest possible. So to find p using the cover-up rule, we are going to be covering up r, and I'll let the rest of the r be equal to 0. So it is going to be 2 times 0 plus 3 divided by 0 plus 1, and then 0 plus 2. So p is going to be equal to 3 over 2. I'm going to do the same thing for q, covering up r plus 1 here. I'm going to let the rest of the r be equal to minus 1. So it is going to be 2 times minus 1, then plus 3 divided by minus 1. Then after that, this is going to be minus 1 plus 2. So q is going to be minus 1. Finally, r here, I'm going to be letting r be equal to minus 2. So it is going to be 2 minus 2 plus 3 divided by minus 2. And then this will be minus 2 plus 1. And I will be covering up r plus 2. And r is going to get me a minus 1 over 2, which means that this 2r plus 3 over r plus 1, r plus 2, you can see that it is going to be written as 3 over 2r. Q is minus 1. So minus 1 over r plus 1, and r is minus half. So minus 1 over 2 of r plus 2. And we're going to be replacing this in the summation notation with this. So now if I were to rewrite this summation notation, r starting from 1 all the way until n of 2r plus 3 divided by r plus 1, and r plus 2. This is equal to the summation of r starting from 1 to n of 3 over 2r minus 1 over r plus 1 minus 1 over 2 of r plus 2. And let's not forget about the overall bracket, because we are summing this entire expression. And I guess from the looks of the expression that we have within the summation, what I think we can probably try is the method of difference. It will most likely work. Let's give it a try. So I'm going to let r be equal to 1, which will give me a 3 over 2 times 1 minus 1 over 2 minus 1 over 2 times 1 plus 2, 3. So 2 times 3, it is 6. Then plus this is going to be 3 over, letting r be equal to 2. So it will be 4 minus 1 over 3 minus 1 over, this is going to be 8. Then letting r be equal to 3, we will have a 3 over 6 minus away 1 over 4 minus away 1 over 10. And let's go for one more row, because I can already see a cancellation. I just want to justify whether the pattern of cancellation exists. So going for one more row, letting r be equal to 4. It is going to be 3 over 8 minus away 1 over 5 minus away 1 over 12. And here is where I see the cancellation, because this is going to go to 0. This will also be going to 0. So we are seeing a pattern of cancellation where 3 rows gives me 1 cancellation, and this pattern seems to continue. I'm going to further justify this by writing down the last 3 rows to see whether this pattern of cancellation is going to persist. So for the last 3 rows, I'm going to let the next n that I'm going to be writing down, next r that I'm going to be writing down here be n minus 2. So it is going to be 3 over 2 times of n minus 2 minus 1 over n minus 1, then minus 1 over, letting r be equal to n minus 2, this is going to be equal to 2n. Then letting r be equal to n minus 1, this is going to be 3 over 2 times of n minus 1 minus 1 over n minus 1 over 2 times of n plus 1. And finally, letting r be equal to n, that will be 3 over 2n minus 1 over n plus 1 minus 1 over 2 of n plus 2. And we can see the same pattern of cancellation because it is here. Okay, this combining with this is going to be equal to 0. So we can be pretty sure that in between all these terms will disappear because of the pattern that we are seeing, which means that we will be left with this term, this term, this term, and this term, this term, and this term. Let's sum these few terms together. That means what I'll be getting now is going to be equal to, let me write it down here, this is going to be equal to 3 over 2, this, minus 1 over 2 plus 3 over 4, which we will be able to evaluate. Then after that, minus 1 over 2 of n plus 1 minus 1 over n plus 1. We will also be able to evaluate this. Then minus 1 over 2 of n plus 2. So if I were to simplify and evaluate this, this is equal to 7 over 4. Then minus away this, I can combine them together to become 3 over 2 n plus 1 minus 1 over 2 of n plus 2. And in fact, this is already what we are supposed to show according to what the question was requesting, because we are supposed to be write it into this form: a minus 3 over 2 n plus 1, then minus 1 over 2 n plus 2. And we are supposed to determine the value of a, this a here, which synchronized with this constant here. Therefore, we can say that a is equal to 7 over 4. And in part 1, we are supposed to explain why this, when it's summed to infinity, okay, why when it's summed to infinity, it converges. So to explain this, I'm going to look at the result of the evaluated summation. So looking at it, I can see that as n tends to infinity, we can see that 3 over 2 of n plus 1, when n goes to a number that is very big, this is going to tend to 0. And we can also see that 1 over 2 of n plus 2, this will also tend to 0, which means that we're going to be left with just a finite value a, which is 7 over 4. Therefore, we can say that summation from r is equal to 1 all the way until infinity of 2r plus 3 over r plus 1, r plus 2. We can say that this converges. And what will it converge to? So let me rewrite it again. So r equal to 1 all the way until infinity of 2r plus 3 over r plus 1, r plus 2. This is going to converge to the value of a. So we can just state this. This is equal to 7 over 4, which should be 1 mark here and 1 mark here. And in part 2, we are supposed to find the least value of n such that this inequality, summation from r is equal to 1 all the way until n of 2r plus 3 divided by r plus 1, r plus 2, where this is bigger than 8 over 5. And I'm going to make use of the result that is from the previous part, where a was found to be 7 over 4 and subsequently this. So I'm going to replace this by 7 over 4 minus 3 over 2 n plus 1 minus 1 over 2 n plus 2. This is supposed to be bigger than 8 over 5. And I'm going to bring 8 over 5 over to the left-hand side of the inequality, which will then give us a 3 over 20 minus 3 over 2 n plus 1 minus 1 over 2 n plus 2. And this is bigger than 0. And I'm going to press this entire expression here into the y1 of my graphing calculator. Let me show you what I have gotten when I press into my calculator. So I got this. Okay, and then what I'm going to do next is to generate a table that will calculate different values of y1 for different values of x. So letting my calculator do that calculation, increasing x by 1 from starting from 0, 1, 2, 3, and so on. So my calculator gives me this. The one thing that I just want to especially highlight to you is that I converted this expression into decimal, so that it's easier for me to do comparison. But for this case here, it is not absolutely necessary because we are just trying to find where this entire expression that we have keyed into y1 is positive. So it is with or without converting it to decimal, it is still easy for us to find. So we can see that starting from 13, y1 will become positive. So which means that the least possible n that will cause this entire expression to be positive will be 13. So from my calculator, therefore, the least possible n that the question is asking for, this is equal to 13. In order for us to do part 3, we need to see the similarity between each of the expression, each of the terms in part 3 here, and compare it to the expression that is within the summation notation. So from a bit of observation, I do think that most of you should be able to see that to get this 9 over 3 times 4 times 5, it is letting r be equal to 3. Because if you are to let r be equal to 3, let me show you. If I were to let r be equal to 3, we have a 2 times 3 plus 3, so 6 plus 3, 9, divided by this is going to be 3. Then after that, 3 plus 1, which is going to be 4. Then after that, 3 plus 2. So we will get a 5. So the other one is 3 plus 2. Similarly, letting r be equal to 4 will get me this. Letting r be equal to 5 will get me this. What I think that it is maybe a little bit tricky is going to be this portion here. Because if you were to look at this for the denominator, we can actually rewrite it. Because we know that in the denominator, there are 3 terms. So for the denominator, if I were to rewrite, it is going to be n minus 1, then n plus 1. And I do have a suggestion. When you have 3 terms that are like this, and if you were to look at the original expression, if the original expression is such that algebraically it is from the smallest to the biggest, it is actually good for us to re-express this so that the expression is also going to be from the smallest to the biggest. For example, the smallest is actually n minus 1. So I'm going to write it as n minus 1, then after that n, then after that n plus 1. Then I will compare the denominator and the numerator to this expression here, and I hope you can see it just as how I've seen it now, because it seems like r is going to be replaced by n minus 1. Let me rewrite this for you to see. So if I were to replace r by n minus 1, we'll be getting a 2 times of n minus 1 plus 3. For the numerator, 2 times n is 2n, and this is going to be minus 2 plus 3, which will give us a plus 1. Then divided by, the denominator can be re-expressed into this way. So this r, if I were to replace it by n minus 1, okay, synchronized to this. This r, if I were to replace it by n minus 1, we will have a n minus 1, then plus 1, which is n. Once again, it's synchronized to this. And for this r over here, if I were to replace it by n minus 1, so we will be looking at a n minus 1 plus 2, which is n plus 1. And again, it's synchronized. That is why I know that for what I have here, maybe I should just write it down as part of my solution. So I'm going to rewrite this as 2 times 3 plus 3 divided by 3 of 3 plus 1, then 3 plus 2. Then plus this is when r is equal to 4. So it will be 2 times 4 plus 3, 8 plus 3, 11, divided by 4 plus 1, 4 plus 2. So 4 plus 1, which is equal to 5, and then 4 plus 2, which is equal to 6. Then plus, letting r be equal to 5, it is going to be 2. Then 5 plus 3. So 10 plus 3 is 13, and this is going to be divided by 5, 5 plus 1, 5 plus 2. So 5, 6, 7. And replacing r by n minus 1, this is what I'm going to rewrite it as. So we will have a 2 n minus 1 plus 3 this is going to be divided by n minus 1. Then after that, n minus 1 plus 1. And n minus 1 plus 2. Okay, this is the observation that we have to make in order to relate this back to the summation expressions, the summation notation that we were working on, which means that this is going to be sum from r is equal to 3 all the way until n minus 1. Okay, so it is going to be this of 2r plus 3 divided by r plus 1, r plus 2. And now what we want to do is to make use of the previous result, which starts from 1 and ends at an arbitrary n. So to do that, I'm going to re-express this as summing from r starting from 1 all the way until n minus 1. I'm going to make use of this. So 2r plus 3 divided by r plus 1, r plus 2. And now we have two more terms as compared to this. It is the first term when r is equal to 1 and the second term when r is equal to 2. So I'm going to minus away the first two terms by expressing them within a summation notation again. So starting from 1 to 2 of 2r plus 3 divided by r plus 1, r plus 2. And now we can make use of the previous result, the one that we have found in the very first part. So I'm going to replace all this n by n minus 1. So a, which was 7 over 4, we found out about it previously, minus 3 over 2 times of, all the n's are going to be replaced by n minus 1. So it will be n minus 1 plus 1. Then minus 1 over 2. And minus 1 plus 2. Okay, this is from this sigma notation. Then minus away this, we can either press into our calculator or we can definitely make use of this same result. Let me just make use of the result. So this is going to be equal to 7 over 4 minus 3 over 2 of 2 plus 1. So 2 of 2 plus 1, this is going to be 3. Then minus 1 over 2 of 2 plus 2, which is going to be equal to 4. And evaluating this 7 over 4 minus this, we will be getting a 5 over 8. And this, if I were to just do a quick simplification, we're going to be doing a 3. We're going to be getting a 3 over 2n minus 1 over 2 of n plus 1.